Okay, so let's finish up this section on net change. Just remember that net change is the same thing as taking the definite integral. So using our fundamental theorem of calculus, the last example we did was talking about particle motion, and we talked about displacement and how that's the same as our definite integral versus distance is the absolute value of our function, and then taking that integral, making it always positive. So then the next thing we're going to look at is, for example 3, we have a falling object, and it says neglecting air resistance, the velocity in feet per second. So velocity feet per second of an object that is dropped from a hovering helicopter is v of t equals -32 times t. What is the displacement of the object after 2 seconds? So what is the displacement after 2 seconds? Okay, so displacement is just our definite integral. So we're going to integrate from 0 to 2. That's our first 2 seconds. And then our velocity function, which we know because it gave it to us, -32t dt. And then we do what we've been doing. So we take the antiderivative of this. So I get -32t squared divided by 2. We're going to evaluate it from 0 to 2. I can simplify this a little bit and get maybe, hello? Okay, well, -16t squared. I'm going to evaluate 0 to 2. So now I'm going to plug this in. So I have -16 times 2 squared minus a -16 times 0 squared. So I get 0 here. And then 2 squared is 4, and 4 times -16 gives me -64 feet. That's it. So that means after 2 seconds, if we write our answer in a sentence, the displacement of the object is -64 feet, meaning it's it fell 64 feet, so it went down, so it decreased. That's it. So just applying one of those new vocab terms. The last example is talking about a profit function. So in terms of economics, so it says the rate of change of P with respect to, oh, let's make that look more like a C, with respect to the number of units sold which is X, is called marginal profit. Okay, so that's a vocab term. They put that in italics. The marginal profit for a product is modeled by dp dx equals negative 0.0005x plus 12.2. And where P is the profit in dollars. So now it wants to find the change in profit when the sales increase from 100 to 200 units. All right, now for this, P is our profit in dollars, and we're given dP dx here. And remember that it said that units sold is X. So I want X, these are X's, X1 and X2. Those are going to be our bounds. So we're going to make an integral when we go from 100 to 200. And we want to find the integral of our function here, negative 0.0005 x plus 12.2 dx. Did I put dx on the last one? Yeah, I did. I put dt. Great. Okay. Anyways. And then I take the antiderivative. Sure, we'll do that in black. So I get negative 0.0005 x squared divided by 2 plus 12.2 x. I'm going to evaluate it from 100 to 200. Now I use my fundamental theorem of calculus. So I'm going to plug in those values. Negative 0.0005 times 200 squared over 2 plus 12.2 times 200 minus all of that again, but inserting the 100 now where x is. If you're on an FRQ, you can leave it like that. If you're on a multiple choice, you'll probably be given a calculator. I don't expect them to make you do that all in your head. But you can find that answer to be 2,000. This one is 2430 minus 12.5. So we get a total profit change of $1,212.50. Okay, that's the change in profit. So when you're given the rate of change of the profit, so the nice thing about this problem that I like, we'll do this in purple, is that it tells you the rate of change of P with respect to the number of units X, and then it gives you the notation dP dx. But when we did related rates, it might not have given you that notation. So when I'm reading this as someone who's doing the problem and I see rate of change of P, I'm automatically thinking dP, and then it says with respect to, so over the change of X. So if they don't give that to you, if they don't give you this right here, then they're going to expect you to know that you can put it in notation like this. All right. So in terms of problems for you to practice, see, 9.5 minutes, not that bad. 2 examples, should have been just a page. Practice problems. What were the other ones I did? I can't remember. Stopped at 11. Okay, so now we're gonna do numbers. 13, 15, 17. We'll take 13 off of there, actually. Change my mind. 15 and 17. And then the AP practice, so 25 through 27. Okay, that gives you 2 practice free response questions and 1 multiple choice. The multiple choice, you can use your calculator. I think actually for both of these, you can probably use your calculator. And yeah, we'll call it a day. Great. Let me know if you have questions, star things, write your questions down, and we'll talk about them tomorrow.